Welcome to a video on determining the average rate of change of a function over a specific interval. Let's start with its definition. Note that the average rate of change is defined as the slope of a secant line between 2 points. So we'll use these numbers here, 1 and 9, as the input values of the 2 points. Now our next step is to determine the output values given that x1 is 1 and x2 is 9. So let's make a note. X1 here is 1, x2 is 9, since we're determining the average rate of change over this interval. Then to find y1, we would substitute that number into the function, evaluating the function at 1, we get 1 minus 2. This equates to -1. Similarly, y2 is f of 9, hence 9 minus 2 times square root of 9, which simplifies to 9 minus 2 times 3, which is 9 minus 6. So that function value is a 3. And those are the y1 and y2, respectively. So the average rate of change on that specific interval, again, is the difference of the output values divided by the difference of the input values. Making our substitution, y2 is 3, y1 is a -1. Divide that by x2, which is 9. Take away x1. And now simplify. You get 4 divided by 8, which is 1/2. Let's consider another example. Find the average rate of change of the function f on the interval 5 to the letter a. So notice that the right endpoint of this interval is in terms of a letter, an expression of a, which means that our average rate of change is going to be defined as an expression in terms of that letter. So likewise, similar to example 1, we'll start with letting x1 be 5, x sub 2 is the value a, then to find their corresponding output values, let's start with y1, that's f of 5, which means that we're going to replace all these x's here with the number 5. Simplify this out, we get 25 plus 10 minus 8, that's 35 minus 8, which is 27. And now y sub 2, that's f of the value a. So evaluating the function at a, we're going to end up with a squared plus 2 times a minus 8. Again, remember, replacing all the x's there with this input value of the letter a. So we get an expression in terms of a. Now, to evaluate the average rate of change, that's defined as y sub 2 minus y sub 1 all over the difference of the x's. So that's going to give us a squared plus 2a minus 8, that's our y2, minus y sub 1, which is 27. Divide all this by x sub 2, which is a, and then take away x sub 1, which is 5. And now we can subtract the numerator. That's a squared plus 2a. We have a -8 minus 27, so that's minus 35 all over a minus 5. Now we want to reduce this expression. So to do this, we need to make sure that the numerator and the denominator are in factor form. So we're going to factor the numerator, which is a quadratic expression. We want to think of two numbers that multiply to the product of the leading coefficient, and the constant term. So we multiply the leading coefficient, which is 1, times negative 35. We get negative 35. So think of two numbers that multiply to negative 35 and add to the linear coefficient. So two numbers that multiply to negative 35, but they add to the number 2. So we can try negative 7 and 5, but adding these is going to give us a negative 2. So we'll switch the signs on those two numbers. So now you can see there, negative 5 times 7 is negative 35, but negative 5 plus 7 gives us the linear coefficient. So this factors into a minus 5 and a plus 7, those two numbers that we were looking for. And now divide by a minus 5. And from here, you can see that this is a common factor. So we can divide that out, simplifying the average rate of change to be the value a plus 7.